This atom has an unstable nucleus. Any moment now, it may undergo radioactive decay. Any time now. Or it may not. We just don't know, as decay is a random event. We cannot predict when any single nucleus will decay. But we can say, if we have a large enough number of atoms, then decay will happen somewhere in a sample. If we time how long it takes for half of the atoms to undergo decay, we have a measure, half-life, of a rate of decay. You have just seen about half of the atoms decay, and it took 5 seconds. So the half-life is 5 seconds. How long will it take for half of the atoms that have not yet changed to decay? Did you say 5 seconds? Yes. In this case, the number of original atoms halves every 5 seconds. You could have a bucket of 100 dice, and after each emptying of the bucket, remove all the ones that show a 6. Repeat until you have about 50 dice left. How long did it take? That's one half-life. If you recorded the time it took for your sample of dice to halve each time, you would get a graph like this. Each halving of the numbers is one half-life. The graph shows 6 half-lives. Half-lives can be as short as nanoseconds or as long as billions of years. If we record the radioactivity of a material over time with a Geiger-Müller tube and a counter, then we can plot activity, or a measure of the atoms decaying, against time to get a graph like this. The graph is for the isotope iodine-131. Notice how the count rate halves every 8 days, so we say it has a half-life of 8 days. Can you work out the half-life of this radioactive isotope? This is the decay curve for carbon-14, which all living things contain. It has a half-life of 5,730 years. Atmospheric carbon dioxide contains a small but constant percentage of radioactive C14, made by the action of cosmic rays on nitrogen molecules. This enters all living organisms via photosynthesis and subsequent food chains. While living, levels are constantly topped up, but upon death, the amount decays away. The ratio of C14 to C12 gives us a way of estimating how many half-lives have passed since death. For example, if a lump of wood contains only 25% of the original content of C14, then the wood has been dead for 2 half-lives, or 11,460 years. There is a limit to how far radiocarbon dating is reliable. After about 10 half-lives, or 55,000 years, there is so little C14 remaining that measuring it with any degree of accuracy is impossible. Short half-life radionuclides are used in medicine, so the patient is safe to go home in a few hours after dosage, whereas nuclear waste has a half-life of many tens of thousands of years. Most of the world's population have some strontium-90 in their skeleton, which originates from the atmospheric detonation of atomic weapons, mainly in the 1950s and 1960s. It has a half-life of 29 years. It will take well over 120 years before it begins to vanish from the Earth. But don't worry too much. We all have in our bodies radioactive isotopes we take in from our environment. For example, bananas supply us with very small amounts of radioactive potassium-40, which has a half-life of just over 1 billion years.
Please like and share our videos with your friends. If you have any questions that you want help with, just comment below.